Hello, this is our Team AC Circuit demo video. I'm Cadence.
I'm Dev Patel.
I'm Stephen Moore.
And we're gonna build an AC circuit for you today. Alright, so first I'm gonna explain how I set up this AC circuit on Multisim. So starting with the power source, when got it is up here. Under power sources, into the AC power one. Once you get to the AC power one, we switch it to the settings we wanted by clicking on it, changing it to the 5 volts RMS and the frequency of 11.87. And then for the resistors, we went up to here, to the basic, went under resistors. Essentially just searched for the ones we wanted, so we did the 680, so we really the 680, and also we wanted the 6.8, so 6.8 thousand one. Pretty much click both of those, set them up in series with each other under the same power source. We got an analog ground, put that down there, connected it all in series. Then up here with the oscilloscope, we got them from over here on the right there, clicked on it, put it there, connected with channel A in parallel with the voltage source, connected channel B in parallel with resistor 2, and then for the multimeter, put it in parallel with the voltage source, but also to get the multimeter, go up here to indicator, and we just went down to voltmeter, and they're just right here. And that is how we set up this high quality AC circuit.
We're trying to figure out the voltage source for channel A, so what we're gonna do is cut off the the VPP. So peak to peak. So what we want to do is, let's bring this down one. We're good. That should work. So we're doing peak to peak. So peak to peak, you want to get the highest point right here, and put the second channel, the first channel closest to the lowest point. So what you'll do, you'll right click, go to minimum, boom, and then you'll also right click for the second channel and go to maximum. So with that being done, this would be your voltage source, 14.12 voltage. Now we're gonna do voltage source for channel B. So what you'll do is you'll cut off channel A by clicking 0, and then click AC for channel B, and then you'll just repeat the same process, which is finding the minimum for channel 1, right click, minimum, channel 1, and then clicking channel 2, and then you're gonna find the maximum for channel 2. The reason you do that is because you don't want to get a negative number. And then again, peak to peak for channel B is 12.83. All right.
Okay. To measure your period or T, you open up your oscilloscope. Take channel 2, drag it to right before the top. Take channel 1, drag it to right before the start. Click on channel 1, right click it, go to next Y max. Click on channel 2, right click it, go to next Y max. That is 84.246 milliseconds is your T for channel A. And then for channel B, what you would do is zero out channel A. Then click AC for channel B. To get T for channel B, you start with putting the pointer right next to the max, right here. You take the second pointer, put it right next to the max. Click on the pointer, go to next Y maximum. Click on the first pointer, go to the next Y maximum, and then you will see right here is 84.246 milliseconds.
Alright, so when it comes to the VRMS and the frequency, when you're looking at Multisim, it's actually listed right next to the power source. So 5 VRMS and 11.87 hertz is the frequency. But also with frequency, you could take the period numbers we received and you could do 1 over whatever the period was for that specific channel, and that would give you the frequency, and they would equal out to the same. So based on the circuit we built on Multisim using a 680 ohm resistor and then the 6.8 kilo ohm resistor, and then with the power source being 5 volts RMS with a 11.87 hertz frequency. Go over here, you can see on the DMM that it's a 5 volts RMS. You look over here and it's 11.86, which is pretty much 11.87. I see it just fluctuated. Hertz frequency. So looking down at the circuit, we're gonna look at the first resistor up there at the top, just so you can see over at the Multisim is the 680. The one in series with it right there is the 6.8 kilo ohms. And essentially what we did is the function generator, just given the power over there, we have the positive going on to the bar up there. We have the negative connected down to the bar over here, getting us the measurements for the oscilloscope. We have both oscilloscopes connected. And the oscilloscope 1 is connected to the first resistor because we're doing it essentially in series with the, or not in series, in parallel with the voltage source. The second one's connected over here. It's going to be in parallel with resistor 2, so we get the resistor 2 measurement. And then, to make sure we get measure the RMS, the positive for that has a wire right there, and then the negative is going to be connected down here to resistor 2, which is the equivalent of being connected to the ground. And so this is our AC circuit, once again with 5 volts RMS, 11.87 hertz frequency, and then the 680 ohm resistor, 6.8 kilo ohm resistor, and that's how we set it up. So for this circuit, as said before, the RMS voltage is going to be 5 throughout it. It's not going to vary depending on the resistor or if the voltage source. Throughout the whole thing, it's going to be 5 volts RMS. And the same thing with frequency, it's going to remain 11.87 hertz for the frequency. So this is the RMS and the hertz and the frequency for the entire circuit, both at the voltage source and resistor 2. So for the voltage source, which is going to be channel 1, so we're going to turn off channel 2 and focus only on this one. So for volts peak to peak, what we're going to do is I'm going to lower it to the bottom line. And this is going to be for the old school way. We'll lower it to the bottom line. No. And essentially I'm going to count the number of squares going up. So looking at it from the bottom to the peak, it looks like it's 3. So pretty much what we're going to do is we're going to multiply 3 by the 5 volts. So essentially that's going to come out to 15 volts. So that's how you're going to get the, So you're going to do the 5 volts, you're going to multiply it by the 3 boxes. You're going to get 15. That's going to be 15 volts peak to peak for the voltage source. And that's how you do it the old school way. Do it the new school way. Just going to hit measure. And you're going to hit voltage. and then you're gonna go down to peak to peak. You just hit that nice little thing. Look at that, 15 volts peak to peak. Just like we calculated with the old school way. All right, now calculating period. We're gonna do the old school way first, so I'm gonna move this up so that it meets like right at the cross, so it's really easy to count it. And then I'm just gonna go to the right, so to the next peak, you're looking at, let's see, 1, 2, 3, 4, 4 with some change. We're doing like 4.2. So we're gonna take our nice calculator, put in the 4.2 box-wise, and we're gonna multiply it by the time down there per box, which is 20 milliseconds. So we're gonna, already said, like multiply 20 PE3 negative. That's gonna give you 0.084 seconds, or if you convert it back, it's gonna be like 84 milliseconds. And that's why we're gonna do that. And then if you're gonna go to confirm it, doing the new school way, gonna hit measure, gonna go down here to time, hit period. Look at that, 84 milliseconds. Both of them about the same thing. So, once again, 84 milliseconds here. It's gonna convert over to 0.084 seconds here.
So we're finding the VPP for channel 2. And by doing that, you have to shut off channel 1. And then you want to bring down channel 2 all the way to the bottom. All right. In order for you to find the VPP, you have to count up because that's voltage and not time. So you'll do 1. That's 1, 2, and I'll say about 2.6. So what I'll do is I'll multiply 2.6 by the voltage. Come right here on the calculator. So that'll be 2.6 times 5, and I've got 13. And that's the old school way. Doing it the new school way, I'll go right here, I'll click measure, I'll go to voltage, and go to VPP, and then the VPP would be 13.4, which is really similar to 13. Alright, so now we're finding the measure for T voltage for resistor 2, for channel 2. The way by doing that, we're checking time, so we're going this way now. So we're gonna count from peak to peak, so it's gonna go 1, 2, 3, 4, but it doesn't stop exactly at 4. So I'll say about 4.2. So what we're gonna do, we're gonna multiply 4.2 by times 20 milli. So we're gonna do 4.2 times 20. Boom, I got 90, but that's before it's converted. So what we're gonna do is we're gonna go to measure time, because that's what we're checking this time, period. And we got 84, which is not far from 90. Very similar, very close.